Alright, in this video I'm going to discuss about the combination of functions with combination of differentiation rules. For example, this case you have the product of exponential function and a trigonometric function. So it's a product, right? So we're going to apply the product rule. As I see that this is your u and this is your v, right? It's a u is an exponential function and v as your trigonometric function. So I going this out, your u will be e to the power of negative 2x and v to be sine 3x, right? So of course you want to apply product rule, you need u prime differentiate negative 2x, salin balik the rules of differentiate exponential, salin balik, differentiate the power, you have negative 2, and the rule of differentiate trigo is the formula, differentiate sine, you're getting cos, and the angles you writing back, right? Then separately you differentiate the 3x, so 3. So you apply the product rule here, so you will have u v prime plus with v u prime, product rule. So u e negative 2x, v prime 3 cos 3x plus with v sine 3x, u prime negative 2e negative 2x, right? So I have applied product rule to this fx. So my first derivative, sorry, I have to write, therefore my first derivative of fx, as I see that here you have common factor, so I'm writing out the e negative 2x. The remaining you have factor in the bracket is 3 cos 3x negative 2 sine 3x. This is the answer for this question. Right, let's continue with these examples. We have fx is a product of a polynomial, a quadratic with an exponential function. So this is also a product, right? It's a product. So you have u to be x squared and your v to be exponential sine 2x to the power of 3. I write this one to be sine 2x to the power of 3. So start differentiating this one easy. You can differentiate this x squared and you're getting 2x. This one is the one that you must be careful. So differentiate exponent. The rule for exponent, differentiate exponent is always the same. You copy back what you have, right? Copy back everything, okay? Then you differentiate the power. Differentiate the power. So you know that the power is sine 2x to the power of 3, right? The power is sine 2x to the power of 3. So you have to differentiate the power and putting here, right? So apply chain rule. So you have, okay, if you differentiate this one, how you differentiate? You bring down the 3, right? Then the sine 2x, then the 3 you minus by 1. Alright, later differentiate the function inside the bracket, which is cos 2x, right? Differentiate sine, you get cos 2x. And you differentiate the 2x, then you have 2, right? You have 2. So overall here you have 3, 2, 3, 2, 6, right? 3, 2, 6, yes, no? 3, 2, 6 sine square, sine 2x to the power of 2, right? To the power of 2 cos 2x, right? Cos 2x. So this is your v prime, right? Your v prime. So, okay. Now you apply the product rule as usual. Product rule u v prime plus with v u prime. So I write bigger a bit. So x squared. So your u will be your x to the power of 2. V prime, v prime. So, okay, I explain again. V prime, you copy back, differentiate the power. Bring down the 3, sine 2x, 3 become 2, right? So then you differentiate the sine, become cos 2x, and differentiate the 2x, become 2, right? And you copy this whole thing here. You have exponential sine 2x to the power of 3, multiply with 6 sine square 2x cos 2x. This is your v prime, right? Your v prime, u v prime. Then plus with v, v e sine 2x to the power of 3, v u prime 2x. Alright, I have done differentiate. So now I want to simplify. I have 6 and 2, I taking 2 out, factor 2. X square and x, I take x. And this one, you see that this is a common factor of these two terms here, right? So e sine cube 2x, right? So I'm taking out this factor 2x, e sine cube 2x. So 6, I'm taking out 2, I have 3, right? So x square, I still have x because I've taken out the x. So this one no more. So from here we have sine square 2x cos 2x, right? Sine square 2x cos 2x. So if you multiply back 2, 3, you have 6 here. So x square. So okay, I double check first. Okay, done. So for this part I have done. So plus with this one have already factored out, right? You already factor out everything. So 2x also factor out, so you have 1. So this is the answer for this question. So look at how I differentiate by using product rule. Let's go for another example. Right, let's look at this example. So this example overall is an exponent to the power, right? This is your fx here. So there are no product. For this function with another function. This exponent with no. So but the power here, there you have product, right? It's product of x squared and tangent x. So means that to differentiate exponent, I have to copy back what we have, right? The rule of, you refer to the rule of differentiate exponent, you copy back everything. Then now we want to differentiate the power. The power is the one that we want to apply the product rule. Whereas your u is x squared and your v is tangent x, right? This is your u, v. So u prime, so you have 2x, v prime. So differentiate tangent, you know the formula, secant square x, right? So now I'm differentiating the power. So u v prime plus with v u prime. So u x square v prime secant square x, right? Plus with v u prime 2x. So then I think I just copy back everything. So I have x square secant square x plus with 2x tangent x. So I just copy back everything. X square secant square x plus with 2x tangent x multiply with exponent of x square tangent x. Alright, this is how I solve this question. Let's go for more examples. Right, let's continue with this example. So this is the rational function with the numerator is a trigonometric function and this is a linear function. So it's a rational functions. I'm going to apply the quotient rule, right? So you have u, you have v. So your u in this case will be tangent 2x to the power of 2, right? Tangent 2x to the power of 2 and v is x, right? So differentiate u prime. So as you know there how to differentiate a trigo with power. So you bring down the power to tangent 2x, right? 2 tangent 2x, 2 minus 1. Differentiate tangent 2x, you have secant square 2x, right? Bring down the power, then copy back this 2 minus 1. Differentiate the tangent, you get secant square 2x. And don't forget to differentiate the 2. So overall your u prime up you will have 2, 2, 4, right? 4 tangent 2x to the power 1 second square 2x. So let's look at v. V equals to x, right? So v prime will be 1. Okay, so let's differentiate this. The first derivative. So the formula will be vu prime minus uv prime over v power of 2 for quotient rule. So vu prime, so v is x, u prime, v u prime. So u prime, you have 4 tangent 2x second square 2x. V u prime minus with u v prime, right? U v prime. So your u will be tangent tangent square 2x, right? Your u v prime, so we have 1, right? So everything divided by x square v square. So you can simplify further. I can just take, you have x here, right? You have x here, so doesn't matter, so I just rewrite everything here. So I have 4x tangent 2x second square 2x, right? 4x tangent 2x second square 2x negative with tangent square 2x divided by x square. I think that's enough as an example for this answer for this question. Alright, okay, let's look at this final question. So we have fx equals to tangent x over 1 plus secant 2x, everything to the power of 4. So it means that if without the power of 4, we know that we need to apply quotient rule, right? We're going to apply quotient rule first. But now with the power of 4, so it's everything in power of 4. So in this case, we need to apply chain rule. So it means the power, you have to deal with the power first. So f prime x. So the first step here will be, you look at how I do. This is everything in the power, right? So it's 4. Bring down the 4. And you have to copy back everything here. You have to copy back everything here. Secant 2x. Everything 4 minus 1. Right? This is the first step. Step 1. Right? Your step 1. So where I deal with the power 4. Everything copy back, 4 minus 1, right? Okay, now we don't look at the 4, but we look at the inside. We look at the function inside here, right? This function here. So this function, tangent x over 1 plus secant 2x, we have your u and v. It's a quotient rule, right? When we want to differentiate the inside function. So tangent x 1 plus secant 2x. So your u will be tangent x and your v will be 1 plus secant 2x, right? So then your u prime, differentiate tangent, you will have secant square x. Remember, the differentiate tangent, you have secant square x. And differentiate 1, you're getting 0. Differentiate secant, the formula will be secant tangent 2x, 2x, right? Secant tangent, follow, the angle follow. So differentiate the angle, you have 2, right? 2 secant tangent. So apply the quotient rule. So quotient rule separately as step 1, bring down the power, copy back everything minus 1, then differentiate inside here. So we're using quotient rule. So the formula will be vu prime minus u v prime over v to the power of 2. V will be 1 plus secant 2x, right? U prime, v u prime. So u prime is secant square x minus with u tangent x, u tangent x, v prime, your v prime will be 2 secant 2x tangent 2x. So everything over with v to the power of 2, v to the power of 2, 1 plus secant 2x to the power of 2. So this is how we doing all this. Okay, we can simplify. We can simplify this, and I have 4, and here you have tangent x, 4 minus 1. 4 minus 1 is power of 3, right? Tangent x, everything to the power of 3, divided by 1 plus secant 2x. So this one everything power of 3. So let's deal with this. So secant square x, right? Secant square x and 1, right? So we have secant square. Okay, let's see what can we do about this tangent x. So I think we just need to simplify, but it's the best here is I'm going to leave it just because you can't see anything that if you want to further simplify, you need to use all the trigo identities and double angle formula, right? So for me, I will just leave this as an answer because I see this is nothing that I can factorize here, because here you have 1 plus secant, here secant square, so this is secant 2x, is different thing, right? So I just leave it, or I just expand everything here. So I can just expand here to be secant square x, right, plus with secant 2x multiply with secant square x. This is 2x, right? So they cannot multiply together. So minus with 2 tangent x, 2 tangent x, secant 2x, tangent 2x. Never write this to be square, they are different, right? So everything divided by 1 plus secant 2x to the power of 2. For me, this is enough, alright? As long you apply the rules correctly, alright? So I apply the power rule. After the power rule, I apply the quotient rule. That's all for this video.